All right, so the other thing that we have to talk about is finding the derivative of bases other than e. So previously we've established the derivative of e to the x is e to the x. However, you may come across derivatives that look a little bit different. So if they have a base something other than e, because remember e is a constant. So if you have something like 2 to the x or even, I don't know, 4 to the x, okay, it's going to follow a different derivative rule. It's going to apply to rule number 1 here. Okay. If you have, if that x, if there's an inside function, so going back to our chain rule, we're just going to stick with the chain rule and just multiply it by the derivative of your inside function or the peanut. And then the other one that we're going to talk about is how do you find the derivative of a log function. All right, so starting pretty straightforward. So again, when you have something that has a base other than e, so when I'm talking about base, I'm talking about that 3 right here. Okay, so notice it's 3 being raised to the power of x. It does have a special rule, so we're going to take the natural log of the base, okay, which in this case is 3 times 3 to the x. Okay, so just the natural log of the base times the original function. Now on here, notice that in here I have a chain rule, right? So I have a u of 3 to the x, and so u prime is going to be 3. So when I take the derivative of this guy, I'm going to take the natural log of 4 times 4 3 to the x. And then I also have to take the derivative of this inside function, right, so the peanut right here, times 3. Now, a more simplified way of looking at this so that we don't kind of have create this mess right here is we know that 4 is a perfect square. So I could rewrite as 4 as 2 squared times 3x. Okay, so essentially what I have is 2 raised to the power of 6x. And again, all I've done is just rewritten this perfect square of a base as 2 squared, because 2 squared is 4. And then I can just take the derivative the same way. So I can take the natural log of the base, which is 2, times 2 to the 6th power is 64, and I still have that x, and then again I still have to multiply it times the derivative. So in this case my u is 6x, so my u prime is just 6, so it's not times 6. So guys, both of these say the same thing. I think this one just looks a little bit cleaner, and you can just do that by just, again, if your base is a perfect square, okay, or an exponent, you can rewrite it. Okay, but those do mean the same thing. All right, on C, so I do have a chain function in this case. So my chocolate in this case is the 5 raised to the power of something, and the peanut is the x squared. So the first thing I'm going to do is I'm going to take the derivative of that by taking the natural log of the base, which is 5, okay, times the original function, which is 5x squared, okay, times the derivative of the peanut, which is 2x. And that's it. On D, again, this is my inside function, that is my peanut, right there is my chocolate, so I'm going to take the derivative of the outside function by taking the natural log of the base times the original function, and then I just have to multiply that by the derivative of this inside function, which is the derivative of 3 is just 0, so negative 2x. And that's that. So again, when you're taking the derivative of something that has a base other than e, you're just going to take the natural log of the base times the original function. Okay, now when you are taking the derivative of a log function, okay, going back to our rules up here, all we're going to do, okay, is you're going to, the derivative of log of a of x is going to be 1 over the natural log of a times x. So notice your a is right there, your x is right here. So going back to the first example, this one's my a right there. So y prime is going to be 1 over the natural log of a, which is 5, times x. And that's it. Okay, so looking at b, you have a main rule here. So my outside function, and that is not a parentheses, but you can almost write it like this. So the outside function is this log with a base of 3, and then the inside function is my sine of x. So that's kind of my peanut there. So I'm going to take the derivative of the outside by going 1 over natural log of 3, because there's a 3 right there, times whatever my inside, right, my x in this case is a sine x, times, and according to my chain rule, I now have to take the derivative of the inside function. The derivative of the inside function is cosine x. So what I really have is cosine of x times the natural log of 3 times sine of x. If you guys want to simplify that a little bit, cosine over sine is cotangent. So you could rewrite that as cotangent of x over the natural log of 3. Okay, so on C, again, I have an outside function of a log, and then I have an inside function of x plus 3 to the x power. So remember, we just talked about how do you find the derivative of something that doesn't have a base of e. So the first thing is, let's take the derivative of log. So I do that by, and when you guys don't see a base, it is a 10 there. Okay, and that's understood. We just don't write the 10, but when you don't have, when you see that little number, that is just going to be a 10 there. So the derivative of just the log is 1 over the natural log of 10 times the original function, so x plus 3, or 3 to the x power, times, now I have to take the derivative of this guy. So the derivative of x is just 1 plus, okay, so remember the natural log of 3 times 3 to the x, right? So we just did on the first examples. And then I'm just going to clean that up a little bit. And so that's just going to be 3 to the x, oops, sorry, 1 plus 3 to the x natural log of 3 over the natural log of 10 times x plus 3 to the x power. Alright, so I'm going to rewrite this a little bit before we take the derivative. So I have log is 2 of, and there's a 3 there, so 2x plus 1 raised to the power of 1/3. Because there's actually a couple of different rules going on. So first things first is I'm going to take the derivative of the log. Okay, remember we're going to do that by 1 over the natural log of 2, okay, times the original one, so plus, or 2x plus 1 raised to the power of 1/3. Okay, and now I have to figure out a way to take the derivative of this. And there's actually, in this case, the log was my shell, the 1/3, oops, sorry. 1/3 was my chocolate, and then the 2x plus 1 was the peanut. So I'm going to go ahead and just take the derivative of raising something to a 1/3 power. Okay, when I take away one exponent, I have negative 2/3 times the derivative of the inside is just 2. So making this a little bit nicer, I'm going to go ahead and move this to the bottom. So I have just a 2, natural log of 2. Just going to go ahead and leave that as a cube root of 2x plus 1 times 3. And then I'm going to go ahead and just, so remember, an exponent of 2/3 means I'm taking the cube root and I'm squaring that. So these guys actually kind of cancel each other out, and it's a little bit easier to see if I still write them as a fraction. So if this is 2x plus 1 raised to the power of 1/3, and this is 2x plus 1 raised to the power of 2/3. Okay, well, you know when you're multiplying, you're adding your exponents. So 1/3 plus 2/3 just gives me 1. So what I end up having is just a 2 on the top. I'm going to bring that 3 to the front, natural log of 2, and this becomes an exponent of 1. So just 2x plus 1, technically raised to the power of 1, but I don't have to write that there. So just going through our tangent lines, again, remember our tangent line is just the derivative, right? So we need their derivative, and then you also need your x and your y. So first things first is if my x is 2, I'm going to go ahead and plug in 2. So f of 2 gives me 6 squared, which is 36. So the next thing that I need is I need to find my slope, which means I need to take the derivative of this function. So remember to take the derivative. It is the natural log of 6 times the original function. So that right there is the derivative. And then I need to plug in my x. Okay, so what I have is f prime of 2 is the natural log of 6 times 36. And guys, if this is a non-calculator portion, which I would expect this to be, it's okay for you to write your slope as this. Okay, if this was a calculator portion, you can go ahead and plug this into your calculator. So your natural log button is right there, so you can plug in the natural log of 6 times 36. And get about 64 point, remember we're going to write through at least 3 decimal places, so I'm going to write 64.5033. And again, a non-calculator, you would not be expected to know that. You can just leave it like that. So my tangent line, remember, is in point slope, so y minus y1 is equal to mx minus x1. So I have my x1 was given to me in the question. The y1 we figured out by plugging it into the original function, and then my slope, right, which is my m in this case, we figured that out by plugging it into the derivative. So y minus 36 is equal to, and we said that was about 64.5033. X minus 2, and again typically we just go ahead and just bring this 36 over, so that this is going to be the equation of the tangent line at 2. Okay, and that's it. Don't worry about number 4, just make sure you guys have these written down.